Hey everyone, welcome back to my channel, and in this video I am going to talk about Llama v2 and how you can use Llama v2 to generate extremely fun and useful stuff. So Llama v2 is the latest LLM release by Meta and Microsoft in a joint collaboration. So I'll show you guys how you can run this on your local laptops or maybe on a Google Collab notebook, and yeah, have fun with it. So let's get on with this video. Recently, Meta and Microsoft in collaboration announced the release of Llama 2. Llama 2 is free for both research and commercial usage. Microsoft and Meta have focused a lot on transparency and access when it comes to the new model. Numerous exercises were conducted in order to make sure that the model was developed in a responsible manner, keeping the best practices of responsible AI in mind. Llama 2 is the latest model in the generative AI field from Meta and Microsoft, and it is expected to be performing at a much better level than the previous models which were released by the organizations. Now, coming to the technicals of the model, the website says that Llama 2 were trained on a humongous 2 trillion tokens and supports a context length which is double the length of its predecessors. Also, the Llama 2 chat models have been trained on over 1 million new human annotations. That seems like a lot of manual work. The Llama 2 comes in 3 sizes: the 7 billion one, 13 billion one, and the massive frickin' 70 billion parameter model. You can also have a look at the benchmark results which have been published. Llama 2 seems to be performing pretty good at most of them. Last but not the least, Llama 2 was trained utilizing RLHF, or reinforcement learning with human feedback, which makes sure that the model understands contexts better based on the different sampling policies, rejection and proximal sampling, which were employed. In order to download the model, users can directly use the link here and submit a form. Once the review is done, Meta would send a link containing the downloadable model files. In order to save time, we would be using this repository over here. It's called Llama 2 7 billion chat GGML. It's under the username The Bloke, and it actually contains all the models which have been released for the 7 billion parameter Llama 2 model. Actually, 7 billion is the one which we will be using for experimentation. And let's move over to the tutorial now. So we are on the Hugging Face page with the Bloke repository. Here we have the Llama 2 7B chat GGML folder, or the repository as you might call it. The good thing is it has all the model files that we will be needing in order to play around with the 7 billion Llama 2. Now, GGML is a very special format which has been created by the GGML.ai organization, and it is a tensor library which is extremely optimized because it has been written in C. It supports 16-bit float support. Along with that, it comes with a plethora of quantization support as well, and a lot of built-in optimization algorithms. The best part is that it has also been optimized for Apple Silicon, so you will actually be able to run these large language models on your personal computer. So if you just visit the ggml.ai website, you will see an example of the 7 billion model being run, like 4 instances of the model being run on a single M1 Pro. So that's extremely cool. And yep, so this seems to be like the new age format of models to come, especially format for the large language models that we are seeing. Now, as you can see, if you like scroll down the website, you will see there's new quantization methods that have also come up. So along with the standard X-bit quantizations, there are a specific type of quantization that these guys have done. So basically they have done quantization at different blocks. So if you look at one of the examples, for example, if you look at GGML type Q4K, so you will see like it's a type 1 4-bit quantization. The 4-bit is like pretty standard, but like they have done it in blocks. So it's mentioned over here that it's like 4-bit quantization in super blocks containing 8 blocks. So they have actually divided up the entire model into blocks, and that's how they have segregated the weights to be quantized. And yep, so they have played around with how much bits are being used per weight. So for this example, it is actually using 4.5 bits per weight, and yeah, so that's how they have managed the trade-off between accuracy and size and speed of the model, I guess. So based on the requirement of the user, these different models can be used. Moving on, Yep, so as you can see, like there are a whole lot of different experiments that have been conducted related to quantization. Yeah, that's the model file as well, the model file that has been provided for each type of quantization that's available. The thing about large language models is, like, if you don't run a quantized version of it, like if you don't run an optimized version of it, it actually becomes very difficult to run it in production. So yeah, if you go to the files and versions, you will actually have access to all the files that are present. Cool. So let's go ahead and install Langchain in our Collab notebook. So as you can see, the latest version of Langchain which is compatible is getting downloaded. At the same time, we'll also just use wget to directly download the model file into the Collab repository. Our necessary imports in, so we are importing the LLM chain from Langchain. We also have a callback manager object being imported. This is our template that we're using. This is just present in the Llama example in Langchain. We pass this to the prompt template, which is going to be our input. At the same time, we also have a very interesting callback, which is the streaming callback handler. So let's go to the Langchain website, and it will show us like what it exactly does. So to give you a very high level idea of what it is, it actually streams the output instead of generating it all at once. I personally feel there are two benefits to this. The first benefit being that you can see the tokens of the generated text being spawned on the screen, giving you a sense of the quality of the generated output. And at the same time, if you are building an application like a chatbot, this will provide a very realistic user experience to the client interacting with the application. Now we are in a good shape to load the model. Let's go ahead and do that. Oops, it seems that we have not installed Llama CPP Python. So Llama CPP Python is actually the Python bindings for the Llama CPP library. So give you a context of what Llama CPP is. It is actually an original port of the Llama model that was created by Facebook. So this C++ library was actually created in order to allow developers to run the 4-bit quantized Llama models on their laptops. So this project has actually improved a lot over the days through contribution from different developers, and now we have Python bindings, which are again used by Langchain underneath to allow these large language models to be loaded into your personal computer or on personal GPU. So that's how well connected the entire ecosystem is, allowing one library to be connected to another, irrespective of whether you are coming from a C++ background or a Python background. We have everything covered. So it seems that Llama CPP is installed. Let's try to load the model, and yep, we have the model being loaded. That was the one that we actually downloaded from Hugging Face, and as you can see, this is the output of the model description. Cool. So as you can see, as soon as I execute LLM, it shows us the model description, and this tells us that the model is loaded onto memory, and this is actually the prompt that we are going to use. We are actually asking it to create a class in order to add student records and teacher records. Now let's go ahead and perform the inference. So we do a LLM and pass the prompt to the model. So it seems that our LLM has started streaming the output. So as you can see, friends, this is the benefit of using the streaming handler. The tokens are actually generated one at a time, and it is being streamed to the standard output. So it gives you a sense of how the LLM is functioning underneath, like generating tokens at intervals and spawning it onto the screen. I think that the inference time is going to bit on the higher end because it is a pretty big model actually, and all the way using 4-bit quantized version. Let's see what the utilization looks like. Actually, let's see what our GPU utilization looks like. I guess there's something wrong. I guess this model is actually running on the CPU and not on GPU at all. But still, let's wait for the final output and see what's the inference quality looking like. Okay, so we have all the methods that we needed generated by the model. As you can see, we have the add student along with a description of that it's an add student method, of course, pretty literally, and okay, so it is actually inserting the student name and Oh, I get it now. Okay, so students is supposed to be a list, and oh no, my bad. Students is actually supposed to be a dictionary with the name as the key, and the value is again a dictionary containing the age and the grade. Not too bad. And we also have the remove student, add teacher, and remove teacher, so on and so forth. And we also have a get students, which returns the lists of students. Well, it has outlined the methods that we would be needing for our student system class, but it still hasn't gotten the syntax perfect. Not from a Python syntax point of view. What I was actually looking for was a class structure being written out. I mean, I guess I would get that out of ChatGPT. I mean, it should be able to do that. So yeah, I see that it's lacking there. But let's move ahead. Let's try to solve our GPU issue as well, and try to see what the output looks like if you invoke it once again. Cool. So I invoked it once again, and now funny enough, it is actually generating the class structure that we want. Not sure what I did there, but the answer isn't consistent with the previous invocation, although this answer looks much better, and it is actually generating the class that we want. Let's wait for some time and see what the final output looks like. I would say that this is actually pretty decent with the entire structure and the checks in place with the capacity and everything. It looks pretty good. So the answers are not too bad. It seems we are getting satisfactory outputs, although I guess I'm pretty sure this would improve if I use the largest version, not the 4-bit quantized one. But then again, the problem that we see right now is that I'm not able to utilize my GPU to the full potential, even though I'm running it on a GPU instance in Collab. So I guess the way I'm installing or loading the library is not appropriate for GPU utilization. I guess I'm missing something here. So what I will do is I will just browse through the internet and try to see where I'm going wrong with this entire compilation of the Llama CPP. I am pretty sure the Llama CPP is not just to be installed with pip install Llama CPP, and some other argument is supposed to be passed in order to utilize CUDA. So let me do that. Let me quickly browse through the internet and see what I can find and get back to you guys. So I'm just gonna go and play this in the fastest way possible. So just hang in there and I will be back in a jiffy. By the way, I'm actually going to change the prompt to and ask it to write a fast API application instead of writing the same class that we had. So it's just to see what the outputs look like, nothing else. So I guess I found the technique to utilize GPU. This was actually present in the Langchain documentation as well for installing Llama CPP, and it was validated by few repos out there which are open source. So basically we have to pass the CMake argument, which is cu blast on, and that is the argument that we set before installing Llama CPP Python, and I guess this is going to solve our issue. Let's go ahead and give it a try. So another more cleaner way of downloading the models from the repository is to use the Hugging Face or HF Hub download module, which is part of the Hugging Face Hub library. So we don't have to use a makeshift wget without any progress bar or anything to download the repositories, but we can directly use HF Hub download. We just need to pass the repo ID along with the file name that we want to download, and it easily downloads the file from Hugging Face. It also returns the path where it is downloaded. At the same time, it also creates a very neat progress bar showing us the progress of the download. So that is very helpful when you're downloading these large models on a server or even your local machine. So as you can see, the download has started. It is telling me that it's 4.21 GB and the progress as well. So as you can see, this is our new model loading definition. So we have two extra parameters that we're passing in order to allow it to load to GPU. One is the number of GPU layers and the batch size as well. So yeah, so this is totally decided based on the model configuration you have, along with the capability of your GPU. The batch size is totally dependent on the amount of VRAM that you have, and the GPU layers is the number of GPU compatible layers that you have in your model. So I've set it to 40 and 5112, which was the default in the configuration, the example that was given. Now let's try to load it and see if our GPU actually, we see a spike in the GPU memory. So that is the expected output. Once this model is loaded, we should actually see a spike. The good thing is that the BLAS argument is set to 1, so which indicates that it's loaded. Oh, and there you go, we have our model loaded onto the GPU. That's 4.5 GB of it. You can actually also execute an NVIDIA SMI to verify if the model is loaded onto GPU or not. As you can see, out of the 15 gigs of VRAM that we have on this T4, 4.6 GB is actually being used by the model that we just loaded. Now that we have our model loaded onto the GPU, let's give it a try. We'll use a previous prompt, the one to create the school system. And look at these guys, and the speed of generation has increased by a huge margin, and the inference is pretty fast. And this is something that can be acceptable in production. I mean, if you have a T4 GPU or anything similar, we can actually make use of this quantized Llama V2 to do some small tasks. I mean, definitely fine-tuning it with your own data would improve it significantly, but this is not too bad either, just to start off with some POC, I guess. And let's check the GPU memory again. It is at 5.6 GB at the moment. Let's try the second prompt also. Let's give that a try as well, which was asking the the model to write a fast API application, and let's see what it generates. As you can see here as well, the inference time has gone down significantly, although the output is not that great. It is going in a loop about how it is not able to write the correct syntax, but we still have a good understanding of how this model can be used to do small POCs with the GPU. And yeah, I'll leave it to you guys to try this model out for different applications. So yeah, we have another prompt here as well, where I just ask it to write the traversal for a binary tree. I will also ask it to write some other Python code. So let's write something very basic, like traversal of a binary tree, and see what is the output looking like. Let's go ahead and do that. So here again, the output is pretty quickly generated, and it is putting the example as well. Okay, so yeah, it has given a simple function, which is not entirely wrong. It is pre-order traversal of the binary tree, it seems, but I guess it works. I guess you guys have a good understanding of how to try this out. I will actually stop the video now and let you guys try out different examples, different experiments with the Llama V2.